Now welcome back. Here we have y equals to cos of hyperbolic inverse x. Okay. Now we need to find derivative of cos hyperbolic inverse x. Now cos hyperbolic inverse x equals to log of x plus square root of x square minus 1 with domain x is greater than equals to 1. With this proof, you can check, you can see one of my videos. Okay. Now here our aim is to find differentiation of this. Okay. I will solve two ways, one over here, one over here. Okay. Now let's find differentiation. Okay, differentiating with respect to x, this is y. Differentiating with respect to x, dy by dx equals to, since law is there, so I will write 1 upon whole term now, x plus x square minus 1 into dy dx of this. So dy dx of x is what? 1 plus square root is there, so it will be what? 1 by 2 square root of x square minus 1 into dy dx of x square minus 1. Okay, dy dx of x square is what? Twice x. Now these two and these two gets cancelled. Here we have 1 upon x plus square root of x square minus 1 into. Now here if I take LCM over here, okay, if I take LCM over here, what will I get? I will get square root of x square minus 1. This into this is what? Square root of x square minus 1. Here I have what? These two and these two gets cancelled, but I have x, okay, plus x I have. Now this term and this term gets cancelled, whole this term gets cancelled. What I have is 1 upon square root of x square minus 1. This is what? D by dx of cos of hyperbolic inverse x differentiation. Okay. Now d by differentiation of cos hyperbolic inverse x is what? This. Now let's solve another way. Now since y equals to cos hyperbolic inverse x, okay, so is implies, I can write is implies, okay, is implies x implies cos of hyperbolic y is equals to x. I can send over here, otherwise you can say multiplying cos hyperbolic on both sides, cos hyperbolic and cos hyperbolic inverse gets cancelled. We have cos hyperbolic y equals to x. Okay. Now here differentiating with respect to x, we have, keep in mind here we have y over here, but we are differentiating what with respect to x. Okay. Now differentiation of cos is what? Cos hyperbolic is what? We have sine of hyperbolic y. Again, we have to differentiate y with respect to x. Therefore, we have dy upon dx equals to dy dx of x is what? 1. Is implies dy by dx is 1 upon, if I send down, sine of hyperbolic y. Now we have identity cos of hyperbolic square y minus sine of hyperbolic square y is equals to 1. Okay, we need sine hyperbolic y. Okay, so I will send it that side. Is implies sine of hyperbolic square y equals to, if I am sending this side, so this will come. Okay, here cos of hyperbolic square y minus 1. Okay. Now since I have sine hyperbolic y, so I need to remove square root. So taking square root on both sides, in order to remove square, if I take square root on both sides, so square root and square gets cancelled. Sine hyperbolic y equals to cos hyperbolic square y minus 1. What is cos hyperbolic y? So here this is what? X. Instead of this, I can write here x square minus 1. Therefore, instead of this, I can write this is what? 1 upon x square minus 1. So this and this are set.